Hi everyone, welcome back. Today we're going to be talking about standard P6C, rational expressions. And our objective today is that we will be able to simplify complex fractions. Now to start, let's first start by just doing a warm-up problem. So in this particular warm-up problem, we're being asked to add two rational expressions, which is what we talked about yesterday. Remember, the way we need to do this is we need to always start by factoring the denominators so that we can figure out what's common between them and what the other one needs. So if I factor this first denominator, this would be an x minus 4 and an x plus 1. Now, looking at my denominators, I see that they both have an x minus 4 already, so that part is taken care of. That's common between them already. The part that is not common is this x plus 1. The one on the left has it, the one on the right does not. So we are going to make sure the one on the right gets one of those. Now at this point, they will both have the same two denominators. So we can move on. So looking at this, my first fraction, or I have to actually combine these together. So we know we'll have one giant fraction. Our common denominator is going to be x minus 4 times x plus 1. And then in my numerator, I'm going to have x, and then this is going to be times, or plus 5x plus 5. Combining like terms, x and 5x is going to give us 6x plus 5 in the numerator. And then in the denominator, we're going to have an x minus 4 and an x plus 1. Now, our numerator cannot be factored any further, so that's good. Less work for us to do. And we just need to restrict our domain. So, of course, the numbers that will make our denominator equal to 0 would be if x was equal to 4. So we're going to make sure that doesn't happen. And if x was equal to a negative 1. So again, we'll restrict that as well. Making this our final answer. Moving on to today's work. Today we're going to be talking about simplifying complex fractions. Now what a complex fraction is it is at least one fraction inside of another fraction. In this situation we have three fractions inside of one fraction. So really kind of a unique situation, something we haven't probably explored too deeply at this point. Now, our steps to simplifying complex fractions are as follows. Step 1, get the expression to be written as one fraction over another fraction by adding or subtracting. Step 2, change the division to multiplying by the reciprocal. And step 3, simplify. Here's what that looks like in practice. So if this was the complex fraction that we were working with, step number 1 told us that we wanted to make it into a fraction over another fraction. And the way we want to do that is by actually adding these bottom two fractions together so that it's just one fraction down there. So sometimes this is helpful for students if they actually just rewrite this as a separate problem. So if we had 2 over x minus 4 plus 1 over x. Now again, this is a quantity, so you need to put parentheses around it to start. Contrary to popular belief, this x is different than this x. We can't just minus 4 from each side. That is not how this is going to work for us. Instead, since this first term is missing call it a just x term, we're going to multiply this by x over x. So now they both have an x in common. Since the second term, or the second fraction over here, is missing this x minus 4, we're going to make sure we multiply this by x minus 4 times x minus 4. Now we will have arrived at a spot where we have a common denominator. So our common denominator in this problem will be x times x minus 4. And then we will have a 2x plus 1x minus 4. And simplifying that, we will end up with 3x minus 4 over x times x minus 4. Now, this is going to take the place of our bottom fraction. Our top fraction hasn't been changed. Now, when I am looking at this problem, anytime I have a fraction over a fraction, we know that we take the top number and divide it by the bottom number. So another way that this can actually be rewritten for us would be if I came over here and I said, well, I have 1 over x minus 4 divided by 3x minus 4 over x times x minus 4. Now, looking at that, this is actually a problem we've seen before. We've talked about how to divide these already. And the way that we divide is by multiplying by the reciprocal. So we can rewrite this as 1 over x minus 4 times x times x minus 4 over 3x minus 4. Now, just like before, if we have any terms that are the same, we can cross-cancel those terms. And that will leave us with x on top, because that's what 1 times x is, over 3x minus 4. And we're done. Let's take a look at another problem. So now we want to make this into one fraction to start. So to make that into one fraction, let's make it into x over 1 minus 6 times x minus 1. Now we know the 1 in front here isn't going to make too big a difference, but we do need to account for the fact that the first fraction does not have an x minus 1. So we're going to multiply by x minus 1 times x minus 1. If you wanted to think about the fact that that first one has a 1, you could multiply the second fraction by 1 over 1 as well, but we do know that that won't change it. Now, working through this, in the denominator, we are going to have x minus 1. And in our numerator, we're going to have x squared minus x minus whatever 6 times 1 is, so minus 6. Now that top may be factorable. We'll look at it here in a moment. But for right now, we will just leave our top fraction as x squared minus x minus 6 over an x minus 1. In our denominator of that fraction, let's make this into 1 over x, or x over 1. Now we will multiply to get a common denominator by x over x. So we will end up with x squared, because that's x times x, minus 9 over x when we combine those fractions together. Now we should factor the top and the bottom, and we'll rewrite it as a division problem. So x squared minus x minus 6, this can factor into be x minus 3, x plus 2. So we can rewrite that as x minus 3 times x plus 2 all over x minus 1. And that's going to be divided by x squared minus 9, which is the difference of two perfect squares. So that can be factored into x minus 3 and x plus 3 all over x. Now remember, to divide, we really want to multiply by the reciprocal. So we are going to take this fraction and we are going to multiply it by the reciprocal of this guy. So this will move to our denominator and x will move to our numerator. Now cross-canceling again, x minus 3, x minus 3. They don't have anything else that's in common right now, so we'll have x times x plus 2 over x minus 1, x plus 3. And we're done. Taking a look at another problem. Again, step number 1 is to make the whole top into one fraction, and then to make the whole bottom into one fraction. So to do so, if I had 2 over x plus 1, that's a quantity, minus 5 over x minus 2, we need a common denominator to put those together. So we will need to multiply the first one by x minus 2 and x minus 2. And we'll need to multiply the second one by an x plus 1 and an x plus 1. Now, once we've done that, our common denominator will be x minus 2, x plus 1. Our numerator is a little bit more complicated. So we will start by distributing this out. We'll have 2x minus 4. We'll tack the negative on up here, and we'll have a minus 5x minus 5. 2x, take away 5x, is going to give us a minus 3x. And a negative 4, take away 5, will be a minus 9. Let's leave that there for now, and let's move to the next one, the bottom. So looking at this one, 3 over x minus 2 plus 2 over x. We are going to need to give this first one an x over x, and we'll need to give the second one an x minus 2 and an x minus 2. When we do that, our new denominator will be x times x minus 2, and in the numerator, we'll have 3x plus 2x minus 4. And of course, combining our 3x and our 2x will give us a 5x. Now from there, we're going to rewrite this complex fraction as the division of two rational expressions. So our first one will stay exactly the same. So we'll have a minus 3x minus 9 over x minus 2, x plus 1. And we're going to divide that by 5x minus 4 and x times x minus 2. Now, at that point, we know that division just means to multiply by the reciprocal. So we will multiply by x times x minus 2. And in the denominator, we'll have 5x minus 4. Now, at this point, we should look for anything that will cancel, which we may or may not have anything. This is a quantity, since that cannot be factored. In our top numerator on the left-hand fraction, we could factor this by pulling out a negative 3 out of both expressions, and that would leave us with an x plus 3. Now, one thing I'm noticing is I don't have any like terms that will cancel other than this x minus 2 and x minus 2. So when I multiply across the top, I will have a negative 3x times x plus 3 in my numerator. And in my denominator, I will have x plus 1 times 5x minus 4. We'll call this part 1 of the video at this point. Part 2 will follow shortly here. Thank you.